Good morning. Uh, Now we'll continue with the matrix multiplication. In that, we have done last time how to multiply two matrices. Now we are coming on the next topic, that is properties of multiplication. In properties, first property which we have already done, that matrix multiplication is not commutative in general. Matrix multiplication, that is AB and BA. In general, they are not equal. So we should say in general, they are not equal. That means the commutative property in general does not hold. In few cases, it can be possible. But every time or any two cases you take, it's not necessary that it will be valid. So we should say AB is equal to BA, not possible in general. That is called commutative property. This you have written. Commutative property in general does not hold. Second thing, associative property. What associative property says, if you take A multiply by B and then whatever result comes multiply with C should be equal to A times of B into C. This property is going to hold if this product and this product is possible. AB is possible, then means ABC are in such a way that you have the product AB possible, then whatever the result of AB comes, that will multiply with C. If these conditions are valid, we will say yes, associative property is going to be equal. So associative property is going to be equal or going to hold if, what you should say, these both sides are existing. If both side product possible, then we will say associative property is going to hold. This is property number 2. Third property says distributive property. That is multiplication we are distributing over the addition. For example, if I say A multiply by B plus C. Now the distributive property says it is AB plus AC. Keep in mind, if A is pre-multiplier, it will remain pre only. You can't write this as BA or CA. No. Position of A should not change. So AB plus AC will be here. This will be called as distributive property. Distribution of multiplication over addition. By the way, if it is written this way, then this should come out to be A into C plus B into C. So this is the distribution. This is also the distribution. So distribution property is also going to be valid. Next property, existence of identity. Existence of identity. This we have done in addition also. That time I told null matrix was the identity for addition. Here we have, if A is one matrix whose order is Aij, order m into n, then my question is what matrix I should multiply that I get the matrix same. One matrix A, what matrix we should multiply that I get it the same matrix AM into N. Now in this case, this matrix, if you multiply with the identity matrix, I told you identity is a very important matrix. Identity matrix, if you are taking an identity matrix, I told you it is a square matrix. Square matrix, diagonal matrix, having scalar also, and then all the elements in the diagonal all must be 1. Then it is called identity matrix. So if this matrix, if you are taking this matrix as a post matrix, then post multiplication, then its order should be m into n, because these two should match. So this, if multiply with an identity matrix, you will get the matrix same. Same way, if it is a pre-multiplier, then this will be m into n. then this matrix should have order, what it should be, m here, so it will be m into m. So if it is acting as a post multiplier, identity will be of order n into n. If it is pre-multiplier, then it will be having order m into m. Both way, identity if multiply with a matrix, always the matrix remains same. That's why this matrix is called identity for multiplication. So identity for multiplication will be I. Here also I. Order is going to depend on its position. It is a pre-multiplier or a post-multiplier. According to that, you are going to find out the existence of identity, and identity is going to be existing. I told you I2. 2 means 2 by 2. It is 1001. If it is I3 into 3, then it will be 100010001. This thing already you have done. So this is the existence of identity we have. So keep in mind, in the multiplication, identity I, if you multiply with the matrix, matrix does not going to change, it will remain same. Next one. Next property, if any matrix multiply with a null matrix, the result always come out to be same. That is null matrix. A matrix order is m into n. Null matrix, now I am taking it is n into p. Then you will be getting another null matrix. Any matrix multiply with I remain unchanged, but when it will multiply with a null matrix, its result is a null matrix again. Order of this will be m into p. So any matrix if multiply with a null matrix, that will remain null matrix. That you should keep in mind. Now here one more thing you should keep in mind. Some question they ask in short questions. Is there any two matrix which are non-zero matrix? Non-zero means all the elements are not zero. Non-zero matrix, but still the product is coming zero. They can ask this. So here, for example, if I take a matrix A, element is 1 0 0 1 0 0. This is one matrix. B is another matrix 0 1 0 0. If I say you write down what is A into B, just check here 1 0 0 0 and then 0 1 0 0. This will be 2 by 2 matrix. This will be 2 by 2 matrix. So yes, this is possible. And the final matrix which you will get will be having P1 1, P1 2, P2 1, P2 2. Can you calculate that? I told you how to calculate this. 1 into 0 plus 0 into 0. Is it 0? Then 1 into, then this multiply with this. What you will find? Yes. In this case, 1 into 0. This multiply with this. Next time this will multiply with this. So that means it is giving 0. Sorry.